What errors we call random errors? Random errors are due to, especially in terms of like about medical, while doing a medical test, we do it, and we tell some particular conditions, right? You should come with an empty stomach. Yeah. If you go without empty stomach, what happens? What happens? There are arises, right? Because of randomness. For example, let's go. Sugar level, we test, right? Blood sugar level. Okay, before meals, after meals. Correct? Why? To get more accuracy. So I want to know my blood, okay, sugar level and blood. So that is based on error. Before meals is we have lower sugar level. After meals, higher sugar level. So we take average of it. That decides our sugar. Okay, it's an error. So different errors we go. Next, combination of errors. In today's class we go combination of errors. What combination of errors here? We go combination of errors. What combination error? The error which is final result as called a net error, we can say. We can call net error. We call net error. In final result, we can get have error. That error is called combination error. In final, okay, all measurements there is a one sum error. Obviously, no instrument gives 100%. So that error, what do you mean, right? That is called combination error. That is called combination error. So first we discuss error in sum or difference. We discuss error in sum or difference. What is sum? Addition. Difference? Subtraction. So error in sum, nothing but this is nothing but we add plus, this is nothing but we subtract. Correct. So let us take we go first sum. For doing this, we are take any two physical quantity measured physical quantity. Let us take I told sugar level at all, right? Sugar level A, okay, then B. Two at two. We need two physical quantities. This is the fundamental physical quantity. But while measuring, if it is added the error, that is A plus delta A, this is B plus delta B. And these two, only these two, delta A and delta B are errors. This is true value. This is it. In the type of the we take this as an absolute error. Okay, and this is called change in right. Why called this? Delta B changing the values because of errors. I repeat. Let's take A, B, any arbitrary, any random chosen physical quantities A and B. Okay. So for example, I want that we know a water temperature is 37 degrees Celsius. But when you measure instruments, it varies plus 1 or 2. So 37 degrees Celsius is the exact quantity. And A, B is true. Then A plus delta A and B plus delta B is absolute. Then here delta A, delta B are errors. Clear? No doubt? Okay. So now delta A, B will take absolute errors. Okay. So now sum is what? Let us take error will be Z. Error will be Z. So A plus B because we take sum. But error, this is okay. Delta Z. This measure value is a error. Delta Z is what? Okay. I'll take sequence step. Z value you know. What's that value? A plus B. Okay. Next. Delta Z.
Delta A plus delta B.
Forward.
Plus
Delta A plus
delta B.
delta B. I should take consider something here. Z plus delta Z. Okay, Z is okay. Then Z plus delta Z. What are taken one second? Yeah. Z plus delta Z. Nothing. What will taken here like this? Going to change it. A plus delta A because Z plus delta Z. Z means A, okay, Z A plus B like this, plus or minus, in place of A I got next,
B.
B plus delta B, correct? Error sum, here will take plus or minus, here plus or minus, here will take addition, because this is
Sum.
any corrections anywhere? Are you reading or not? This first beginning, you should be perfect with this. Anywhere you have error, please ask. Anyway, in the error, in doubt. Yeah? That is clear? Okay? Shall I go next?
Yes, sir.
So, I will rearrange the terms. Why? Because I have z equals some value here. I have z equals some value. I want to rearrange. The rearrange should be in proper fashion that it should be equal to that. That's why z plus delta z equal to, I'll take rearrange a plus b plus or minus delta a plus delta b. Correct? Any changes? Sure. Next step, what do you do? Okay. Next reflection. What will be the next step? The good at mathematics. Okay. Nice. Think, it's okay. Even if it's wrong, don't worry.
Substituting sets for
Okay.
yes.
Substitute that value. If substitute that value, these two cancel. Perfect. That value. Because z equal to a plus b, a equals b. So both sides same term. Towards LHS and RHS. Can neglect? Can cancel? Yeah. Then delta z is equal to what I got?
Delta A
Plus delta b. This is final error. I mean combination of error for sum. Similarly for difference. Will you try difference? Do it. You done? A and B. Rewrite A and B mention. Capital A and capital B. Capital A and capital B. Two physical quantity. Capital A, capital B. Two physical quantity have measured values. A plus or minus delta A and B plus or minus delta B. Now you are right. Delta A, delta B are absolute errors. Delta A and delta B are absolute errors. Delta Z means delta Z equal to error in sum. Delta Z means what? It is error in sum. So, and final, what is this mentioned here? Actually, I should take one more thing here. Plus or minus here. Like this. So, what's the maximum error in this? We'll take plus or minus here. We should carry this one. Maximum error, what will be maximum error? Yeah. So, maximum error, see, delta Z equal to delta A plus delta B will be maximum error. Correct? Maximum you can add. If subset will be minimum error. Right? For example, if this is 0.2, this is 0.3. Maximum error is 0.5. Minimum error is 0.1. But always consider maximum error. This is maximum error. Instead of not came on. And for difference, what did it? Delta z equal to a minus b. Delta z equal to d. Z equal to d, a minus b, not delta z. So this is sum equal to a plus b here. For difference, a minus b. What an answer? What answer?
Sum so delta A plus sum minus delta B for minimum delta A minus delta B.
So we got. So ultimately we can say, but in conclusion, therefore the absolute errors due to sum or difference always add up, right? Always add up. We got something this one, right? Check here. Delta equals delta b, you got this one, right? In your answer, final answer. Yeah? Yes, sir. That means what? And sum or difference doesn't matter. Always the error should be added up. If you do difference also it add up. If you do sum also it will go to add up. Okay? Now error due to product. Error due to product. Errors delta A and delta B. Correct? So what's z equal to? A into B. Perfect. Then what is the A plus delta A into B plus delta B. Correct? So now we have to do multiplication. Then how to multiplication? A with the first term, then A with the second term. Okay, we do multiplication. So A, B. Next plus A delta B. Okay, plus B delta A. Correct? Plus delta A into delta B. Perfect. Any corrections? Nothing. So next. In this one, this we can angle at y. See, error itself is small. Okay, in terms of point itself, look very small. Both errors are very small. If product happens, product also very small. For example, right where we take like 0.1 into 0.1, 0.1 to 0.2. Answer is 0.2. These errors are okay, these errors that are very small. So we neglect this. Of neglecting, what do you got? AB plus E delta B plus B delta A. Correct? Any more changes here? Nothing? So now which some comma here? Z and so what is left? So what is it equal to? A delta B plus B delta A. Let us divide this equation divided by AB. What to do? Why? Because here all uncertain or uncertain. One sambandham no related, right? So to make it look good, we have to make a foundation. Right? So this foundation works better. Why? Because this is skin friendly. This friendly? Skin friendly. Why? Because AB code something I taken here. Don't know dot product doesn't matter. Dot product, vector product. Just cross multiply AB. Correct? So now if you apply foundation, you check what happens. Delta Z. AB means Z is equal to here. A delta B by AB, B delta B by AB. So now A, what left? B cancels. What left here? Delta Z by Z is equal to delta B by B plus delta A by A. This is your final what? Error, right? A product. Any doubt? Please free to ask. Why you neglected? I told you. Neglect. Because very small. Finished? Yeah. So remaining two homework. Which are homework? Quotient and exponent. Take it up homework. Combination error. Quotient and one more. Exponent. You do quotient right, you get same answer. You do quotient right, you get same answer. I think you done in college, right? You got same answer. No doubt. Yeah. So next, dimensions of physical quantity. For dimensions, what dimensions we discuss here? Dimensions is what? Expressing given physical quantity in terms of power of them. What dimensions is what? Expressing the physical quantities in terms of power. In terms of power. Okay, better. Dimensions of physical quantity. The power to which base quantities are rise to rise to represent base quantities are rise to represent physical quantity. Quite if you understand, right? Underline the keyword base quantity. Base, yes. What base quantity is? So for dimensions, we follow some important parameters which are separate universally. That's right, universally. So it required explain. So we take mass, right? Mass. What's the unit of mass? Kg, right? This is kg. And this in terms of by dimensions we measure in terms of what? We show in terms of m. M means mass. And make sure the dimensions we measure in terms of square bracket, just like a king who's sitting on the elite. Where king sits? Huh? Where king sits on? Queen Elizabeth. They have their respect place, right? Respect, okay? So that is in a bracket. With that much respect, we show for the dimensions. Okay? We can put flower bracket. The good square. Because well balanced. Well balanced. So mass. The next. Length. So what kind of length? General, SI. Meter. So all taken SI. Okay. SI. What is the first letter there? L. L is the dimension for length. Perfect. So mass, length. Next we go with the time. Time in measured in terms of seconds. Or it takes S, small s. Okay. So time means T. Or first alphabet we kept in a bracket. Check. All we kept in a capital. Mass, length, time. Next. Temperature. Okay. Don't try my temperature. Temperature? Measure in terms of Kelvin. What about? You want T again? Yeah. But temperature we show generally in terms of what? You can take K also, capital K also. Okay. We have two things here. K or we measure in terms of theta. Yes? Yeah. What is the one next? Current. Electricity. Current, huh? Current symbol? Ampere. Okay, show bracket. Yeah. We measure in terms of amps. Right? We measure in terms of amps. mass, length, time, temperature, electricity, current, or electric current. Anything electric current will give, but it's better. Electric current. Next. Another one is enough. Go further, I'll explain. Because we repeatedly use these only. And actually, right, maximum use these three star mark. Maximum use these three only. First, mass, length, time. Yeah, now let us validate with your definition. Let us validate this with our definition. You can underline base quantity thing. It's a power expression in terms of power is of physical quantities. How? Right? Yeah. One thing. Let us express velocity. First we do. Velocity. Unit we know meter per second or distance covered by time. Perfect? Yeah. Meter as per these dimensions, what here? L. Okay, very good. I'll express in terms of L. Okay, next. Time. T. L by T. Make sure don't forget to put bracket. It's quite look odd. First of all, don't flow. Right? Make it in normal, all are equal. L. Denominator equals numerator, it become? Huh? What is it for? Ulta thing. To make it straight, you should give one right, one slab. Then it becomes? Tell me what minus 1. Correct? Perfect. Now, tell me. L and T are basic quantities. Okay? And you can see right on minus 1 is available on T. T to the power of minus 1. That means what? The physical quantity is expressed rise in terms of, we did some word, right? The sentence, read it.
The power to which base quantities are raised to represent physical quantities.
Perfect. So, again, okay? Raised to represent physical quantity. What raised? Which power is raised? Base quantity power will rise. What base quantity here? T. T means time. Time means second. Dimension quantity are those which won't represent. Okay? They are powers of base quantity are raised to represent physical quantity. Velocity is a physical quantity. You can measure velocity, right? Yeah, the velocity is a physical quantity. So you can check raised. And make sure we express this dimensions in terms of homogeneity. What homogeneous mixture? Meaning homogeneous mixture. You heard?
Yes.
Heterogeneous, homogeneous. Homogeneous means
Completely mixed with exception.
completely.
Completely mixed.
Okay. Next.
Both are soluble.
Both are soluble. Okay. One more points now.
Concentration between
Okay. Example.
sugar solutions.
Sugar. Water. Right. So good. So here we take homogeneous in the what? They all the components all in same state. I mean same chemical composition and same state. For example, I can't take mixture of oil and water. Oil and water is not homogeneous. Why? They're not soluble. They create a layer. It's called heterogeneous mixture. Homogeneous, but all should be unique, same. That's why. So always try to express all physical quantity in terms of homogeneity. What homogeneity? Like this. I'll show you. In terms of MLT system, all you have to show in terms of MLT. M either available or not available. If not available, put 0. L available, right? L to the power of 1, T to the power of minus 1. That's why, right? Always should show the powers. L available or not available, should show power. This is called homogeneity. It means we give respect of each and every dimensions. There are two factors, right? So let's put cap to everyone. Let's respect as the soldiers. Soldier, police model, police lathi, topi, compulsory. Right? So here for this also required compulsory the cap with their word, which are wearing either 0 or 1, 2, 1 doesn't matter. Based on the physical they wear. Constable wear topi रहते when you get constable, when you go PSI, so on so level, right? The cap changes. Same fashion. Next, shall we go? Acceleration. Can you tell me acceleration?
Meter square plus.
Yeah, what take? We take meter per second square. So if you express in terms of dimensions, how would we look like?
T minus 2.
First m to the power of 0, L to the power of 1, T to the power of minus 2 under square bracket, because all sitting in a free chair. Hope getting it into your mind. No doubt. Not that much makeup here. Just so now we discuss basically now. So what are the different type of dimensions available? Different type of dimensions available. There are various dimensions available. For example, dimensional variables. And they are different area, density, resolution. Okay, you take even force. Force also have different dimensions, right? So this is called dimension variables. What do you call? Dimension variables. Dimensional variables, like I told, force, velocity, next acceleration. Because see, check, all have different dimensions. Let's go force. Force. Unit of force. Newton. Rima. F equal to ma. So ma के लिए some dimensions है. Ma m for mass. Mass to the power of 1. Perfect. Acceleration, you know very well. M what 0 means 1 will get. Then L to the power of 1, T to the power of
Minus 2.
minus 2. This is the force dimensions. Dimension of force. Then your favorite. Which city?
Density.
Density of water, how much? You learn properties of solids, properties of fluids. You must know density. Need put the thank you. Then dimensions of unit of density. Okay, very good. You know? Equal. Then tell me, density of water, how much? Good. You speak, doesn't matter, right or wrong. Density of water is how much? 1000 kg per meter cube. We take density of water how much? Rho W of water. This is visible. Rho. How much? 1000 kg per meter cube density of water. This is at STP, standard temperature pressure. Nothing but water having highest density at the temperature of 4 degrees Celsius. What temperature? Out of the box. At temperature of 4 degrees Celsius. Water having highest density at 4 degrees Celsius. If you measure density of water available in this container is not equal to 1000, which is less than 1000. Getting point? We generally take, right? Assume standard value. The standard value is 4000 kg per meter cube only at 4 degrees Celsius. But we take it for our granted, for our calculations. Just like you go to purchase our red dresses, they are standard size. Small, medium, large, extra large, double XL, triple XL. So the size of fixed is standard. And we restrict as per our food content. This is standard. Okay. Now, let us express density unit in terms of dimensions. Yeah. kg. Nothing but mass to the power of 1. Meter cube to the denominator we have. If you take numerator,
-3.
then to the power of -3. What about time? 0. So time to the power of 0. This is the homogeneity. Check homogeneity always expressed here. Next, dimensional variables. We discuss now. Different dimensions. Right? Force different, acceleration different, exertion different, and density different. Next, we go dimensionless variables. Next title, dimensionless. So how it sounds different. Less, sugarless. One sugarless tea. Correct? Huh? One sugarless tea, one less than sugar nahi one less tea. Correct? Less than what is less meaning? Less than तो बड़ा कठिन sugarless. So dimensionless. Dimensionless. That means for some physical quantity properties, we don't have any dimensions. Example: specific gravity. We have specific gravity of oil. We take 0.9, 0.8. Specific gravity means with respect to point between less than 1 is equal to 1 is specific gravity of water. Specific gravity less than 1. Getting point? Dimensionless. Next we go. Strain. What strain? Suicide brother. When tired because I was too much strain. Strain. Change in dimensions to original dimension is the ratio of change in dimension to original dimension. It's called strain. Okay. Next we have trigonometric constant sin theta, cos theta, tan theta. For that we return dimensionless, but having values. It may be dimensionless. Mean nothing but do not have any dimensions. Good examples. Strain, specific gravity. Strain, specific gravity. Next, dimensional constants. Dimensional constant. What is this? Dimensional constant. Listen. For this dimensional constant, it having dimensions. It having both dimension plus value, so called constant value. this dimension constant, it having dimensions plus values. Other different ಆಯ್ತು. ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ಡೈಮೆನ್ಷನ್ ವೇರಿಯಬಲ್ಸ್ ಇದೆ, ನೋ ಡೈಮೆನ್ಷನ್, ಇಲ್ಲ ಡೈಮೆನ್ಷನ್ಲೆಸ್, ನೋ ಡೈಮೆನ್ಷನ್. ಬಟ್ ಇಲ್ಲಿ ಹೇಳ್ತೀನಿ we have dimensions, we have values. Example, acceleration due to gravity. ಕರೆಕ್ಟಾ? When the value model is 9.81 meter per second square, if we shoot m l t to the power of 1 minus 2. We got speed of light. Has it? Speed of light in vacuum. 8 meter per second. Meter per second available. 3 divided by 8 will do. How it will? It's constant. Yep. Mass of electron. Something here. 10 minus 19. In it? Angstrom line. AMU. Amul. What AMU? Atomic mass. I told the first class, right? You symbol taken for mass. Atomic mass. Next. Next one. Speed of light at all. You just add a no. Speed of light. Speed of light. How much? 3 into 10 raised to 5 kilometer. Huh?
3 into 10 to the power 8
Kilo. 8 kilo. 1 kilo got 10 raised to 3. Don't forget. Dimensions. M, L, T. Turn. Check. 0, 1, minus 1. Next, dimensionless constants. Which one?
Dimensionless constant.
Very good. Less, sugarless. This time I should repeat. Less. ಪಾನಿಪುರ ಹಣ ಖಾರ ಕಮ್ಮಿ ಇರ್ತೈತಿ, ಕರೆಕ್ಟ್? ಬೇಲ್ ಮಾಡೋದು ಹಣ ಖಾರ ಕಮ್ಮಿ, ರೈಟ್? So less, but here dimensionless but has values. Very good. This is different, something different, right? But it is dimensionless but having values. So how can I identify? Dimensionless, think carefully. Dimensionless, we can't write dimension for that, but it having values. Here, dimensional constant, both having value plus dimensions. Less. Example. Guess. Because it's less. Can you guess? Specific gravity comes under dimensionless variables. Specific gravity doesn't have any dimensions and no value. Less, not value. Illi less. No dimensions, no values. I mean fixed values. No fixed values. It varies based on the application. It has value. Okay. Has values but no dimension. Example, if you told, correct? ಯಾವ್ದಾಗಲಿ ಗೊತ್ತಾಗಿದೆ ಅಂತಿರೋ ಕ್ಯೂರಿಯಾಸಿಟಿ ಗೊತ್ತಾದ್ರೆ ಇರಂಗಿಲ್ಲ, ಇಷ್ಟೇ ಅನ್ಸುತ್ತೆ. ಹೌದು, that is human tendency and which is true. Yeah, let's collect. 5 value
3.54
or 22/7. It having any value in dimensions? Would have having value. Why the students using the right 3.42 use for calculation? or 22 by 7. It has value, but no dimensions. Next, E, exponential. We'll take by convention logarithmic we'll later on. You must use logarithm table in a lab. Other time you come to know. By discussing mathematics, we get this term. Log E, e to power of minus 1, e to power of 2, e to power of 3, we get E, exponential we call exponential. Then next, the pure numbers. Pure number 1, 2, 3, 4, 5, 6. We say right in school. These are all dimensionless, but having values. 1, 2. First rank is what? Value 1. Third rank, 100. Third. So having values, but no dimensions. Dimensionless constants. So all clear? Any doubt, anywhere, any point? If anything you have anything issue, you just clarify.
Rydberg constant.
Kichunu?
Rydberg's constants.
Louder.
Rydberg's constants.
Rydberg's? Spell it.
Rydberg.
Rydberg constant. Okay, it has values. Constant means value. No unit.
Yes.
No unit. It comes on a dimensionless constant. You want to get Planck's constant. H. Level. Planck's constant. For Planck's constant, you don't have dimensions. Both are like your dimensions value as well as values. Just like this, right? We have some constant pi. No unit for this, no dimension, but we have values. All comes under this category only. Dimensional variables, dimensionless, dimensional constant, and dimensionless constants. Okay, we done all the things. What's the use of this? You should learn the use, right? Where is applicable, sir? What's the use of this? All nonsense things you don't know will use. Then use the really correct? It won't come, it can not be available for our life. But dimensions plays very important role for validation of given formula. If you told any formula, B equal to U plus 8 told, motion formula. Whether you should right or wrong, you can verify by the dimensions. To verify any formula, whether true or correct or wrong, we use dimensions. Then it helps in conversion from one physical quantity to other physical quantity. I repeat, it helps in conversion of one physical quantity to other physical quantity. First one, to check equation is correct or not. To check equation correct or not. Next, also check. It also says that it also uses the relation between fundamental units or quantities maybe. Relation between how velocity and acceleration related, and how density and mass related, how force and mass related. So it gives a relation between them. It gives relation between them. And you can check any formula we can verify through dimension analysis. Make sure that LHS equal to RHS. LHS means RHS?
Right hand side.
That's it. That's called dimension analysis. We just want, we'll try one. Which you try? Which formula, your favorite formula in motion? Yes, equal to ut plus half at square. And one thing I'll tell you, magnitude doesn't matter here. Magnitude. 2, half a little, point a little, 1 to something it will be, right? Does not affect anything. Affect this equation. Magnitude. only consider the dimensions. So let us go for this. LHS must be equal to RHS. LHS. S. S is distance. What's the dimension for distance? In terms of MLT. MLT. M0, L1, T0. Correct? Yeah. Make sure other remaining terms towards our RHS should be same. All terms. First term we take 1, 2. Term number 1. Okay. UT. Very good. U means velocity. Initial velocity. Okay. What's the velocity dimensions, please? MLT.
M0.
If you want to write it, second. M0. And don't do this M and M, okay? Small and capital M. Yeah. M is meter. So M1 T raised to minus 1. So clear? Okay? In a square bracket. One more T for time. I mean M0, L0, T1. Don't multiply, we get what to do? We take same M0 to the power of 0, 0 to 0, 0. Then L to the power of 1 and 1 plus 0. 1. Power should have, right? Then plus 1 minus 1 cancel, 0. What is left? M0 L1 T raised to 0. Next term. Same equation number small a, equation number small b. We'll do reverse go. Then second term of a square. A means meter per second square. T means time. Half is a magnitude. You won't consider, to be frank. A dimensions, please. M, L, D. Tell me. M to the power of 0. A to the power of 1.
T to the power of minus 2.
Minus 2. Again. M, L, D towards this one. Second term. Second bit. M, 0, L, 0, D to the power of 2. Now, final touch. M0, 0 plus 0?
0.
0. Very good. L, 1 plus 0? 1. T. Minus 2 plus 2. Sure. That's our question, correct?
Yes, sir.
Yeah. Equation number C. What do you got? All equal? Different. So, hence, A equal to B equal to C. It is valid. Equation is valid equation. It is perfect. Correct equation. No error, nothing. No error, nothing. Remaining formula you have to work out as a homework. Remaining how many formulas? 3 and 4. V equal to plus 80. V square equal to AS. Next one.
V is equals to U plus
First one V equal to plus 80. V square equal to AS. Next one. This one. One more, check once. First, finish writer. When is exam come? Next week, huh?
Yes, sir.
Today? Which paper? Do you have any exam today?
Yes, sir. 17.
17 to?
31st.
Okay. 31st.
Yes.
How many days you are taking?
Long gap for this only initially taken long gaps. That Diwali cake.
Okay.
27th.
This because on 19th Monday. This is when and this. Monday. Right. On Monday.
17th Monday.
Today. 10th, right? Okay. Okay. Yeah. Wednesday. Yeah, everything you have to work out, remaining formulas without fail.